So the Cobot Makerspace is a new facility at the university, and it's one that the Beacon has established. And it's about human scale robotics, and in particular how humans and robots can work together. In fact, in that case, the robots become called cobots, a collaborative bot. Facilities unique at Nottingham. We have some great robotics facilities already, particularly in engineering, where you've got kind of industry scale robots, the sorts of robots that have to be in cages because they're that kind of big and that dangerous. In this facility, it's much more about robots that everyday people will come into contact with. They might be service robots, they might be what we call telepresence robots, where you can project yourself into another space. Might be a robot at a workbench that you're alongside doing some manipulative task. It might be a factory cleaning robot that you have to work with. So the Smart Products Beacon it's a very interesting marriage of a couple of things. On the one hand, there's quite a lot of kind of manufacturing and engineering in it. It's about making products as you might normally think about them, physical things that we have. The other kind of part of the marriage is the digital side, where we're really thinking about how digital technologies add to the consumer experience. They make those products do new things, and people even contribute to the products through their own stories or their own data. So the Beacon brings together that kind of engineering focus with that digital, almost social media focus, and puts them into one place. So smart products, put simply, are digitally enabled products where data and AI and immersive technologies somehow extend the products. There are all sorts of smart products you might think about. Some of them are kind of really obvious. If you think about like social media, think about something like YouTube as a product. It's clearly digitally enabled because it is digital. Others may be less obvious. Think about a car, the automobile. Now, I would argue as a computer scientist that a car is more software than hardware these days. It's like a computer on wheels. That's how you should think of a car. It's controlled by software, it records data about how you drive it. As cars become more autonomous in the future and you just get in and out of different vehicles, it's the data that is the car, not the rubber and the iron that's actually on the road. So there are various reasons why you want to get into research in smart products. If you're a researcher, then it's going to extend the work that you already do with new perspectives. So if you're an engineer, then suddenly engaging with this kind of agile digital world of social media is something that gives you new challenges, new opportunities. If you're a computer scientist, then thinking about what happens when software hits the real world, it becomes embodied as a robot or something, that raises new challenges. If you're from law or humanities, where we also have lots of researchers in the Beacon, then there's all sorts of kind of ethical questions or questions about the nature of the human experience that again you can get into. So as a researcher, there are lots of reasons you want to do it. Of course, there are other reasons we do research as well. One that's hugely important to us is impact. The research we do here is unashamedly applied. It's about creating new opportunities for companies and the economy because we're trying to make new kinds of products. It's about solving problems through those products, the future of well-being and healthcare, for example, the future of transportation and sustainability. So the research that we're doing in the space, it ranges from understanding how people interact with such robots, both, if you like, at quite a fine-grained detail, as in we've got people who are developing touch interaction, haptic and force interaction, looking at conversational interfaces to robots and so on. Also some bigger questions. We're interested in, if you like, the ethical and responsibility questions around what such robots mean. We're also interested in developing the technologies themselves, so haptic interfaces, and ultimately we want to push back into developing the hardware. So there's a mixture of off-the-shelf kit here but also increasingly an ability to make things. So one of the interesting projects within the Beacon, I think, is the factory cleaning project. And this is exploring how teams of robots and humans can clean things together. So we've got robots here, for example, that can sense and clean things that humans normally can't. They use high intensity ultraviolet light to clean sort of an environment. They're actually really dangerous to be in a room with as well. So when you switch them on, you need to be outside. But of course, humans are also great at cleaning things and understanding what needs to be done. So, we're looking at how robots and humans could work as a team and demonstrably clean things in a kind of better, more accountable way. We've got some projects here that are looking at kind of creative and performance uses of robots. So we're working with a spin-out company called Makers of Imaginary Worlds, and they do kids theatre and installations. Very successful, they're touring lots of work. And they've been looking at kind of turning robot arms essentially into dancing machines. So the robots can track children as they move around them, and they can kind of respond through their movements. So that's looking at a very creative application. On the other hand, as we watch how the kids interact with the robots, we start to learn a great deal about how people think about robots and might engage with them. So we've projects that are looking at how humans and robots might manipulate things, either remotely or side by side. So there you're kind of working next to a robot arm. You're teaching it by perhaps moving it or moving its twin, and it's kind of learning from you. Maybe ultimately it can observe you. Or maybe the robot arm's remote and it's manipulating really dangerous stuff. Think about what's going on inside a nuclear reactor, for example, and you're kind of remotely controlling it, but you're feeling it better. You've got some kind of force feedback. So that's another area we're looking at. So, we're very excited that one of the new appointments we've made in the Beacon, Professor Praminda Kaleb-Solly, she's leading a team that are doing rehabilitation robotics. So this is very much thinking about how robots can help people recover, can move them, can potentially even socially interact with them as kind of part of healthcare. One of the interesting kind of robots we've got here are what you call telepresence robots. Actually, they're kind of quite lightweight. They look a bit like an iPad on a stick, and you can take kind of remote control of this and essentially be part of a social environment that's somewhere else. In fact, one or two conferences I've been to, you could actually hire these kinds of things out, lease them, and project yourself into the conference. But of course, there are huge numbers of questions about really how do such objects find their way around the world, what happens when they get lost or stuck, how do other people react to them, and how could they get into wilder environments? What happens if I wanted to go to a music festival or just shopping down the local shopping centre?